This is the presentation for the Unit 4, Lesson 4 problems. All right, and so in the first one, they give you two different ways that May and Tyler worked out the equation to get a solution. May's solution is b equals negative 25, and Tyler's solution is b equals negative 28. Well, the first thing that you should notice in May's solution, she had 2/5. She had 2/5 b, which means 2/5 times b, plus 1 equals negative 11. What May did was it looks like she added 1 to both sides, and that would have gave her 2/5 b equals negative 10, but that is incorrect. You can't do the same thing. There's the same sign. You have to do the opposite sign. So what May should have done for her equation is she had 2/5 b plus 1 equals negative 11. She should have subtracted 1 so that the signs are different right here. They're opposites because we're doing sad map, so you do the opposite of what you see. And this would have been minus 1. And then you would have to keep change here. So this would have been negative 11 plus negative 1, which would give you negative 12. So May's solution is not going to be correct. On the other hand, if you look at Tyler, what Tyler did, Tyler took a totally different approach than May. Tyler said, okay, I got this fraction that I don't like, so I want to figure out a way to get rid of the fraction. So Tyler said, okay, I'm going to just make this 2b. Well, in order for this to just be 2b, you have to multiply by 5. That way, the 5 and the 5, because this will be 5 over 1. The 5 and the 5, the same thing divided by the same thing makes 1. And then I'll just be left with 1 times 2. And that'll give me 2b. And remember, whatever I do to one term, I have to do to every single term. So that means I would have to multiply this by 5 too. So I have to do times 5, and I would have to do times 5 to this term. So that will leave me with plus 5 equals negative 55. And that's the mistake that Tyler made, because he did not multiply that 1 by 5. He only multiplied the 2/5 and the negative 11, but he didn't multiply the 1 by 5 as well. So both of their solutions are incorrect for that reason. All right, the next one. Problem number 2. If I can stay on problem number 2. Problem number 2 says solve this equation right here. All right. In order to solve this equation, we need to distribute. So I'm going to write the equation. 3 times x minus 4 equals 12x. So the first thing we're going to do is distribute rainbows. For my little rainbows, that lets me know that this 3 has to be multiplied by each term inside the parentheses. 3 times x is going to be 3x. 3 times negative 4 is going to be negative 12. And that's going to be equal to 12x. And then I have x terms, but they're on different sides. They need to both be on the same side. So red rover, send a term like me over. The 3 is going to go over, and it's going to go over by doing the opposite of what I see, because remember, we're doing SADMEP. S-A-D-M-E-P. Reverse PEMDAS. And so instead of adding 3, because this means a positive 3 because I don't see a sign, I'm going to subtract 3. So I can have different signs. Subtract 3x, sorry, not just 3, but 3x. This is going to make 0, and I'm just going to have negative 12 is equal to 9x. And now I want x by itself, so I'm going to box it in. Whatever's not in the box has to go. So the 9 has to go to this side over here, and it has to go by doing the opposite of what I see. This whole expression right here means multiply, so I'm going to divide to move it. And x is going to be equal to negative 12 ninths, which can be reduced. Divide this by 3, divide this by 3, and x is going to be equal to negative 4 thirds. Okay. All right, and the next one, problem number 3, says describe what is being done in each step. What has been done in each step while solving the equation? Well, if you look in the first step, they distributed. They took the 2, multiplied it by the negative 3x, and got negative 6x, and multiplied 2 times 4 and got positive 8. That's all they did for the first step. So the first step was distribute the coefficient, which was 2. So step 1, distribute the 2. And then the second step, so if you look here, let's see what changed. Well, 8 stayed on this side, so 8 didn't change. The negative 6x is gone, and now the 5x is also gone. And so something happened on this side, on both sides actually. And what happened was we added 6x to both sides. So that's what happened. So step 2 is to add 6x to both sides. Add 6x. And then after we added the 6x, we got step number 3. We got a equal to 11x plus 2. And now the 2 has left from the right-hand side of the equation. And so that means we subtracted 2 from both sides because we have to do the opposite of what we see. This says plus 2. We have to move it by subtracting 2. So step 3 is to subtract 2 from both sides of the equation. And then step 4, in order to get x by itself, we have to move what wouldn't be in the box. So if I had the box in this x, 11 wouldn't be in the box. And I will move it by doing the opposite. This expression right here means multiply. So I'm going to divide by 11 because I'm going to do the opposite of what it's saying to do. And I will be left with 611. So step 4 is to divide by 11. Divide by 11. And that's how you do problem 3. Problem 4. Problem 4 says Andre solved an equation, but when he checked his answer, he saw his solution was incorrect. He knows he made a mistake, but can't find it. Where's Andre's mistake, and what is the solution to the equation? So we need to find Andre's mistake. So if we look here, Andre, it looks like he distributed the 2. And I'll just write this out so we can find his step. So let's just work his equation, and then we'll find his step, his mistake. Negative 2 times 3x minus 5 is equal to 4 times x plus 3 plus 8. And you're going to distribute rainbows. And you have 2 coefficients, one on either side you're going to distribute. So this would leave us with negative 2. I'm sorry, when we distribute, we're going to end up with, let me clear that. Try that again. Negative 2 times 3x minus 5 is equal to 4 times x plus 3, in parentheses, plus 8. And we're going to distribute the negative 2. And that's going to give us negative 6x. And a negative times a negative is going to make a positive. So that's going to give us positive 10. And then we're going to do the same thing here. On this side, 4 times x is going to give us 4x. 4 times 3 is going to give us positive 12 plus 8, and that's what Andre should have. And he does have that, so there's no mistake there. The next step would be to combine the like terms, where these terms are alike, so I can combine them. So I would have negative 6x plus 10 is equal to 4x plus 20. There doesn't seem to be a mistake there with Andre's work. So then the next step, it looks like they took the negative 6x and moved it over. So this says negative 6x, so I'm going to add 6x to move it. And that's going to disappear. And up here on the other side, so I'm going to have 10 is equal to 10x plus 20. And there's Andre's mistake because he ended up with 2x. So Andre just looked at the 4x and the 6x and just subtract them, said negative 6x plus 4x and got negative 2, and that was incorrect. He was supposed to do the opposite because we're doing sad math. You're supposed to do the opposite. So that is Andre's mistake. All right, and number 5, Problem number 5. Problem number 5 says, choose the equation that has a solution. That has the solutions 5, 7, and 8, 13. Well, we can just figure out, we know when we have 2 points, we can figure out the slope. So we can just do the slope. We have 5, 7, and we have 8, 13. And sometimes I write mine like this, and I just subtract like this. So I say 7 minus 13, because this is my y2, minus my y1. It's going to be, or I can read it backwards and say 13 minus 7, so I can have positive numbers. So I can have 13 minus 7 equals 6, and that's over x2 minus x1. And since I did 13 first, I have to do the 8 first. So I'm going to have 8 minus 5 on the bottom. 8 minus 5, that's going to give me 3. So my slope is 2. And now I just need to find my y-intercept. To find my y-intercept, I pick one of these points, and I pick the slope, and I substitute it in. So I'm going to use the 0.57, and my slope is 2. And I'm going to plug that into y equals mx plus b. So every letter is going to be a number except b, because I'm solving for b. Y is going to be 7, because that's the value of y in my ordered pair. Slope is 2. X is 5 plus b. So I'm going to have 7 is equal to 10 plus b. I'm going to subtract 10 from both sides. And b is equal to negative 3. So my equation would be y equals 2x minus 3. And so when I go over here, that is D. So D would be my answer. Y is 2x minus 3. All right, number 6. Number 6 gives us this picture, this graph, and it says a length of ribbon is cut into 2 pieces to use in a craft project. The graph shows the length of the second piece, X, for each length of the first piece, Y. How long is the ribbon? Okay, so the graph shows the length of the second piece, X, for each length of the first piece, Y. So if you look at this, graph, this number on this axis is representing the length of the second piece in feet, and the number on this axis, which is the y-axis, is representing the length of the first piece. It says, how long is the ribbon? Explain how you know. Well, if I take and I just write ordered pairs, some ordered pairs from what I know, all right, I can come up with a ratio. So for this, if the first piece is, let's just go here. So if this is my x-axis, I'm going to read this axis first. So at 0, length for my second piece, the first piece is 15 feet. So when the second piece is at 0 feet, and I can write that as an ordered pair, the first piece is going to be at 15 feet. That's one ordered pair. Then if I look at 1, when the second piece, because this axis is the second piece, when the second piece is a foot long, the first piece is 14 feet long. So then I have another ordered pair, 1, 14. And at 2 feet for the second one, when the second one is at 2 feet, the first one is at 13 feet. So I would have 2, 13. And this should look familiar to you. Ordered pairs and using ordered pairs to find slope and all of that. And we know our y-intercept. Our y-intercept is the starting amount. So we know that the ribbon is 15 feet because this is our starting amount at 0 feet for x. For the second piece, the first piece is 15 feet. So when I don't have a second piece of ribbon, the length of the ribbon, before I cut the ribbon into 2 pieces, so like if this was my ribbon at 15 feet long, and then I folded it in half, so say I folded it in half like this, right? That's me folding it in half. The length of this ribbon altogether is this piece right here stretched out flat. This is when I folded. This is when I stretched the ribbon out flat. So the ribbon would be 15 feet. Because when the second piece is 0, that means I haven't folded it at all. I just got it laying flat. At 0 feet, the first piece of ribbon is 15 feet. So this distance from here all the way down to here is 15 feet. Now when I start folding it, then I will have a piece of ribbon at 1 foot. We said 14 feet. The first piece will be 14 feet. The second piece will be 1 foot. So that'll kind of look like this. 14 feet, and then I fold it a little bit, and that's 1 foot. And then as I keep folding it, for at 2 feet, it'll be 13 feet. The second piece will be 13 feet. So it'll get a little longer until it ends up evening out. So the first piece of ribbon is 15 feet. It says, what is the slope of the line? Well, you can do the slope of the line easily. You can just pick 2 clean points and do rise over run. You got to look at the scale though. The scale here is going up by 1. The scale here is going up by 1. So if I say, all right, I'm going to go from here to here. That means I have to go down 1, which is a negative direction, and then I have to go right, which is a positive direction. So I'm going down 1, which is negative 1, and then over, because it's vertical over horizontal, and then I have to go right 1, which is positive 1, so my slope is negative 1, because a negative divided by a positive is a negative. And then the last question there asks, explain what the slope of the line represents and why it fits the story. The slope of the line represents like how you're bending the ribbon. So it represents every foot of ribbon. When you lose a foot of ribbon from the first piece, you gain a foot of ribbon to the second piece. That's kind of what it means, like this. So instead of being a straight line like this at 15 feet, I took it and I bent it so that a foot of it folds over. So I lost a foot from this piece, but I made a second piece that's a foot long. So every time I lose a foot from the first from one side, I gain a foot on the other side until eventually the ribbon is going to be 2 equal pieces like that. Okay, and I think that is all of lesson 5 or lesson 4. Practice problems lesson 4.